going to have another little 30-minute session here. We're going to take a break from talking about some of the tools and hardware and talk about how you understand the I/O. So you've got your application running. Maybe it doesn't perform the way you thought it would, or maybe you're not sure if it's performing the way you thought it would. What do you do to find out? So you guys will know better than me that a lot of scientific domains are becoming more data intensive. If you don't have an I/O problem, you will later. And our computers are getting more complicated. So what do we do to figure out what's going on when all the applications are different, all the platforms are different? And so there's some questions here. What things can we measure in the storage system or in the application? How much overhead is that going to add? Is that all right? How do we analyze the information that we extract? How can we find the performance problems? And then, of course, we're not just doing this for fun. You want to turn it around and make the applications better. So I'm going to talk about a particular tool that we're fond of called darshan for characterizing application I/O. So what is darshan? All it is a characterization tool. It won't make your I/O faster or slower. It just looks at what's going on. And the idea is that it captures a kind of compact representation of the I/O behavior in an application. And you don't have to change your application to use it. There's no code modifications. And also, one of the claim to fames of this particular tool is that it doesn't have much overhead. So you can just leave it on, have it collect data. If you need it, that's great. If you don't need it, that's fine too. And in fact, a lot of facilities now have darshan turned on automatically. So to use darshan or have it instrument your code, you don't have to do anything. You just log in and run your code. Darshan will be running there beside it. And even a lot of facilities that don't have it in that mode, they have it available as a module you can load in your environment. We'll talk about that later. And once you've run a job that has darshan turned on, what you get at the end is a summary that tells you how many I/O operations you had, how many reads, how many writes. Gives you some counters, how much time was spent in I/O, how much time was spent doing metadata operations. And you get some histograms to kind of give you an idea of whether the operations were small, large, how many data types were used, that sort of thing. So to kind of make it work in this mode, it's just a library that links in with your application, just like an MPI library or anything else. And it has wrappers that intercept the I/O calls and collect a little bit of information about them as they're passing through. And it takes a little bit of memory on each rank to store this data. It's a bounded amount of memory, so it's not going to eat your memory allocation that you have. And then when the application shuts down, it gathers up all this information, merges it together, does some compression, and writes it out. So there's no extra communication while your application is running, no extra storage while your application is running. It waits and does that at the very end as you're shutting down. And you have this little log file at the end that you can process with some tools to get an idea of what happened. The log file that darshan produces is a binary file, but we give you some tools that let you parse it and make graphs and things out of it. The most common one is called darshan job summary. This is like kind of the initial, I just want to know what's going on. This is the first tool to run. And what it'll do is it'll take a darshan log and produce a PDF file that has some graphs kind of summarizing what happened. But a few highlights up here in red, it'll tell you the estimated performance. So this particular job got 8 gigabytes per second. It has some graphs showing you what percentage of your runtime was spent doing I/O. So those are the two first things you want to look at. Was my I/O fast or slow relative to what you expected? But even more importantly, was it a significant part of your runtime? So sometimes we have applications investigating a problem, and we look at it, well, the I/O is not as fast as it could be, but then we look at this graph and it's only 1% of their runtime. They don't really want to do any more I/O. It's hard to justify optimizing in that case. So you want to see if it's a significant problem for your use case. And then getting into more detail as you go through the PDF, you can see what access sizes were common, what access types were common, and then how many files were generated or were read. So were they big files? Were they small files? Were they a mix of reads and writes? And one thing that we found that I always find interesting to mention is that some of you know the application codes that we run often have a very long lifetime. They've been worked on by a lot of people. And sometimes it's hard to find one person who understands everything in the code and much less understands everything about the I/O. So sometimes this serves as a good sanity check. You're like, well, we're doing I/O this way. I know it's good. And then we look at the graph and it turns out it's not quite like that. Someone changed it somewhere along the line. So this is also a good kind of, are things working the way I thought they were? And so that's kind of the primary use case, is taking a job that you've run and look at its performance. But from the systems and kind of administrative perspective, there's other things we can do. Because darshan on a lot of facilities is turned on for all jobs, that means there's kind of a constant library of data being produced. And we can go back and mine this to look for trends, see if things are changing with how people are using the storage system. You can look for particular behaviors that might be red flags. You can reach out to the users and say, hey, we see you're doing this, maybe it's not great. So as an example of what kind of stuff you can find, this chart is from a study we did on a previous generation system at NERSC, where we mined all the darshan logs to look for kind of ad hoc heuristics. And one thing we looked at was, well, how many jobs are doing a lot of metadata? Metadata is like opening files, closing files, seeking, setting attributes, stat, that sort of thing. They're not actually moving data to and from the storage media. And so if you're spending a lot of your time doing metadata, you're not doing as much effective I/O as you like. And so we filtered how many jobs are spending a lot of time doing metadata, and a lot of them were. The worst offender that we found spent 99% of its I/O time in metadata. So for every minute of time they spent interacting with the storage system, less than a second of that time was spent actually moving bytes to or from the storage system. So what we'd like to have eventually, this isn't the way it is now, but these are kind of, right now this is a on-demand thing that systems administrators may do when they're looking for a problem. We'd like for this to be automatic, of course. It'd be nice if something sent out an email and warned you if something was going on, or at least warned an administrator, but we're working on that. So the performance, I won't spend a lot of time here, but basically this graph shows running a I/O intensive benchmark with 4 different builds, no darshan with an old version of darshan, a new version of darshan, new version of darshan with some extra features. And basically it's hard to tell, to pick out the darshan overhead from the regular variants that you're going to have on the system anyway. These newer versions of darshan is what's installed on the Theta system at Argonne and the Cori system at NERSC. The older version of darshan is what's on Mira, but this is another example of how variance is kind of an issue on the system. And then the only other thing that darshan can take a little time on is when it shuts down and compresses its data. Of course, if you have a big job, there's a lot of information to collect, but this is a pretty heavily tuned part of this tool. And if you have an application that's doing large shared files, it's pretty rare that the shutdown time will take more than a second. So you're adding a second to your total application runtime to get this data out. If you're doing file per process, then it can cost more. This is in this particular, these are on the Edison system at NERSC. We had some jobs that if they're doing an extraordinary number of files, they may take 5 seconds extra to shut down. So generally, this isn't something you're going to notice, but it gives you a lot of extra data. So how do you use it? So on Mira, Cetus, Vesta, Theta, Cori, or Edison, you run your job. When the job's over, you look in a particular log directory. They'll be divided up by year, month, and day. On Theta, this is in the path that I have listed here. You can look on the website. I'll have some links at the end of these slides that tell you where to look for your particular system to find the path. And then you can find the log that corresponds to your job, and then you use some tools to analyze it. On some of the other systems, like Titan at Oak Ridge, darshan is not in the default environment, but you can add it. You just do a module load darshan, compile your code, and you've got it. And so what this looks like, so this is just submitting a job. You can look for the job ID right there to make sure you can identify which job you have. That usually comes out on the standard out on all these systems. Then you look in the log directory. In this case, there's a 2017 June 29th place, and you can find the log that corresponds to that particular job. It'll also have your username and the executable name to help you find it. So once you found the logs you want, so I decided I wanted everything from that day that I had run. You can copy them out to another directory. They're usually fairly small files, but you might want to check and make sure. Depending on the system, you can either just run the job summary tool directly. On the nurse systems, you'll want to load a LaTeX module first to make it work. So this is just another recap of what you can see on the summary. But the important thing is, did you spend much time doing I/O? You know, what access sizes were there, and how much data was moved? If you keep going through the multiple pages, there's more and more detail. The second page gives you a timeline that shows. So from the left to the right, that's the total execution time of the application as a timeline. Going up and down, that's the ranks, how many processes you had. And it draws a line anywhere there was I/O activity. So one of these is the bottom one is writes and the top one is reads. So you can see where in your job you're doing the I/O. A lot of classic applications will have phases of I/O, but that might not be the case. And then I'm not going to go through all the graphs that are in there, but it gets a little more and more detailed as you go down. There's also a tool called darshan parser that will just take everything in a log and spit it out in text format. This is not where you want to start. But if you're looking at this and you really want some, the precise numbers, what is that time range exactly for this one that took a long time? You're going to probably want to look at the parser output. So that's pretty much darshan in a nutshell. I can give you a few kind of tips for, you look at a darshan log, it didn't tell you what you wanted, what are your options? So one thing that may happen, if you're doing shared file I/O, this is what your timeline might end up looking like. The top two graphs show file per process activity, so there's none in this case. The bottom line shows shared file activity, and you just get one big stripe. So it doesn't know which processes access the file when, because it's been collapsed into a single kind of data point. Now, does that matter? Maybe, maybe not. If you suspect that you have a skew problem, maybe some processes are taking a lot longer to do I/O than others, this isn't great. You'd like to see a breakdown, but you can do that. There's an environment variable, and this is in the darshan documentation, called disabled shared reduction. That turns off the feature that collapses all the data into one record, and it gets you back to a graph that looks like this. So if you see a single line on the shared file and you want it broken down per process, rerun your job with that environment variable set. It's not the default because it makes a little bit bigger log file, but it works fine. And then the next thing, suppose you want even more detail than that. One thing that you can't tell from here is what individual I/O operations made up a given streak. So is this 100 I/O operations from here to there, or one big I/O operation? That level of detail isn't there. But darshan can also provide a full trace too, exact every single I/O operation in a list for every single process. Now this is very much not something you want to leave on all the time because it costs more. That's a little bit more expensive data capture. But again, it's something you can turn on demand when you, I've got the wrong thing highlighted, but it's this enable I/O trace, DXT enable I/O trace. And this is a relatively new feature in darshan, but it's available on the nurse system, it's available on the Theta system at Argonne. And what you end up with if you turn it on is you can run a parser tool that will list every single I/O operation. So this is rank 0, it did a write, it started at offset 0, it was 1 megabyte write. Started this time, ended at this time. So everything you ever wanted to know. It can also tell you on Lustre-based systems what storage servers you touched for each I/O operation, which is kind of neat. So that can give you an idea of how balanced or your I/O might be, or if there's hot spots along the way. So those are just the two extra things I would turn to if you don't see what you want in the regular darshan output. So Darshan's an active project. It's in production, but we keep trying new things to make it work a little bit better. I'll just give a hint to things that are going on. One thing that's not really a future thing, but it's already there, is the instrumentation in Darshan has been modularized. So there's the wrappers that tell you about what happened in HDF5 versus MPI versus POSIX versus things that are on the system. They're all separated. They all get their own little section in the log file. And the reason that's important, not just as software engineering practice, but it means that if someone thinks of a new I/O API that's important to them and they want it instrumented, a module can be created for it. It won't hurt anything. It won't break any existing log files. It's sort of an extensible file format. So this is kind of a nice way to get involved with other I/O libraries or other I/O hardware if you want information about it. And we're working on adding some new stuff to it now. The other thing I wanted to talk about, and this is kind of future looking, so Darshan doesn't take a lot of slides to describe it since it's a straightforward tool, but it doesn't tell you everything. And especially when we talk about variability in I/O, there's other things that might impact performance besides what your application said it would do. There could be problems beyond your control. Maybe the storage system's slow, maybe a disk drive's slow, maybe other jobs are running. And it's just a little hard to get the big picture of what else happened. You're just getting a slice of it. So the analogy I like to make is kind of looking at it as climate versus weather. So I live in Atlanta, Georgia. It snows there sometimes, not very often. But if it does snow, is that normal? If I just told you that it snowed, what would you think? Well, I just told you it snows there sometimes. It's possible. Is it the right time of year for snow in Atlanta? Right now, it is absolutely not. Is the temperature sane for when you would expect to have snow? Did you see snow or your neighbors too? So there's a lot of things that kind of validate whether this is a plausible scenario. And similarly in I/O, if you run a job one time and you get one performance, how do you know that was normal? How do you know that was within the expected range, or did you have something really severe happen? So to do that, we have to get data from a lot more places than just Darshan to get kind of a big picture view. And the good news is all the parts of the storage system that we've talked about today have instrumentation. The bad news is they're all different. It's all different file formats, different data collection mechanisms. So what we're doing right now is working on a project called Tokyo that will try to combine all these things into one big picture view. And again, it's not writing new tools. It's just finding a way to integrate data and produce kind of a unified view of what's going on, not just what your application did, but what other parts of the system did, how the storage system responded to it, and come up with analysis tools that can give you some context for what your application encountered. And so this is largely a kind of a data mining, correlation, visualization effort. And we've got to give you an idea of what this will mean, hopefully before not too distant future, this could be a production tool, but this is an example of a dashboard built on top of Tokyo called Umami. And what it does is it can take a given job, your application, and look for historical samples in the past of that same application running with similar parameters. So every time Phil's simulation has run with a 2 terabyte data set, it finds them and plots them over time, and you can see the performance going up and down. In this case, we've got as high as 50 gigabytes a second, 25, sometimes down pretty close to 0. And it can create that box plot to tell you, are you in your normal range? In this case, the most recent run with the star here is much faster than usual. And then we stack that with a lot of other metrics from this taken at the same time. So what was the CPU load on the servers? How much space was left on the file system? Different things like that. So that not only do you see how did your job perform, but what was the system doing around it. And sometimes you can see things that correlate pretty closely just by looking at a simple kind of comparative graph like this. So this particular example, this was a good day, right? You got really good performance. So the question is why. One of the first things we look at, coverage factor, tells you how busy the rest of the system was relative to your job. That doesn't really seem to have much of anything to do with the performance. It doesn't match up with it. But we saw that the CPU load almost was inversely proportional to the performance of the job. So the CPU load is a big deal. But why did the CPU load suddenly get lower that day? In this case, it's because the file system was getting fuller, and fuller. Admin sent out a mean email and said, hey, you need to delete some data. People went and deleted data. Space freed up on the storage system. The servers didn't have to work as hard to find blocks to put your data on. So because the file system wasn't as full anymore, servers aren't working as hard, your job gets better performance. So this is the kind of thing that if you just looked at Darshan and you said, well, I ran it this day and it's this speed, I ran it this day, it's this speed, you can't tell much just by looking at the application. You need some context. So that's what's coming in the future is we hope that this will be something that, first for admins, they can look and get some context about what's going on, but I'd like for this to be something that, day-to-day users can access to. So I'll talk a little bit about Handson Exercises. There's a Git repository here that has not just darshan, but it has links to material for all the presenters that we've had today. But for the darshan stuff, you're welcome to try it. And in fact, I encourage you to try darshan on your own application. If you have jobs you can run on the NERSC or ALCF systems, run them. Have a look at the darshan log. Or if it's not there, ask for help. Or if you want some help understanding it, we'll be here tonight to talk about it. Myself and Rob will be happy to answer questions about it. But if you don't have your own application that you want to run, or you just want to find some more controlled examples, we have a few kind of made-up applications you can try. There's 2 of them. There's 2 versions of each application that one's good, one's bad. So the idea is you try to run it with darshan, see if you can tell which one's faster, see if you can use darshan to figure out why one of them is faster. And again, you can use it on most of the systems we have access to. If you're running stuff at Oak Ridge, just load the darshan module first. And that's about it for darshan. We'll talk about the HDF data management libraries next, but does anybody have any questions about that? Yeah.
So how does darshan compare to, like, say, Gangly or some other passive monitoring system?
So the main thing is that darshan isn't a service that runs on the nodes and watches whatever's there. It's linked specifically to one executable. So that changes the scope, right? So it doesn't necessarily get the whole system, it just gets one job, but it also means that we can run MPI, for example, and do really scalable compression and reduction algorithms. So.
For other systems, an Argonne system or other systems where it's been tested.
Yep, so darshan runs on pretty much any system that we're aware of, with the caveat you have to have MPI. So it depends on MPI, but there are instructions on the general darshan webpage for setting it up for different kinds of systems, and I'm happy to help if.
So I mean, it sounds like this is meant mostly for collecting statistics for processes that are meant to sort of have a beginning and a middle and an end, right? So the job that gets scheduled, right, it's going to start up at some point. You know it's going to end when your time slice ends, right? This would be really valuable. I think at least it'd be valuable in some of the stuff I work on, which is long-running server processes that may fork off individual worker thread or worker processes, but the main server process is going to stick around for a long time. Is there a way to tell it to dump out sats periodically, or in some other way monitor long-running server processes?
No, is the short answer. But we are interested in that. Do you know Raj Kudamuthu?
I certainly do, yeah.
Yeah. So I've had some discussions with him about how hard it would be to get that on the data transfer nodes, and we know.
Exactly what I was thinking.
Yeah. So that's something we would very much like to do, but it will take some work. So I think it's a good idea too. We just haven't gotten there yet. Yep. All right. Well, with that, that's the end of the darshan material. Thank you very much.